Hello, my name is Marcus Chavez and I'm with IFARA TV. Today we will be cablecasting segments of the press conferences that were held during the 22nd CROI, which is the annual conference on retroviruses and opportunistic infections, which took place in Seattle, Washington this year. This segment will be presented by John Frater, who is with University of Oxford in the UK. John talks about SPARTAC, which is a short-pulse antiretroviral therapy at HIV seroconversion. SPARTAC is a randomized controlled clinical trial that looks into treating HIV-infected patients with ARTs for short periods of time, and if by doing so could slow disease progression and delay the need to restart treatment.
Okay, so thank you very much, everybody, and good afternoon. So again, our work is focused on this concept of what happens when you stop antiretroviral therapy and when does your virus come back, and particularly inspired by the Visconti cohort that you may be familiar with. In patients who treated an early infection, there seems to be something special about patients early on. If you treat early and stop therapy, it is completely different to what happens when you treat a chronically infected patient and stop. And in Visconti, we know there are about 14 patients who have not rebounded many years after stopping therapy. Our work comes from a study called SPARTAC, which was a large trial of antiretroviral therapy in primary infection, 360 patients in all recruited over a number of continents. And our work is a sub-analysis of patients in that study who had treatment for 48 weeks in primary infection. Within about 10 weeks of being infected, they went into ART for 48 weeks, and then they stopped. This time last year, we presented data showing that if we measured DNA levels, HIV DNA levels, at the moment that you stop therapy, that predicted time to rebound. And we know that in these patients, 14% were undetectable a year after stopping. So there is something different about these patients. They're not behaving like you'd expect them to. So the study we've just presented is taking this work a bit further and looking to see are there other markers as well as DNA that might help us predict what happens when you stop therapy. So very similar to the work that Jonathan has been doing. We focused more on the immunology. We've been interested in HIV immune responses and then markers like activation markers, CD38, HLA-DR, and then more specifically markers called immune checkpoint markers or exhaustion markers that have lit up the world of cancer medicine and seem to be really important there. Markers PD-1, LAG3, and TIM3. And when we measured these markers in our patients, what was interesting, at the moment that they stopped therapy, 48 weeks after treatment, and they stopped therapy, the markers didn't really tell you very much. But if you then went back and actually measured those markers from samples on the day they started therapy, the three markers that stood out were PD-1, LAG3, and TIM3, these exhaustion markers, these immune checkpoint markers. Activation and the other markers that we thought might matter didn't matter, but these three things stood out. It's hard to explain why, but it opens up a number of very interesting questions and hypotheses as to what is the nature of these cells, that when you start therapy, there is something inherent about them, that when you stop therapy, these cells wake up and other cells don't. So I think this adds to the data, that DNA helps predict rebound. These three markers, again, open questions as to mechanism, which we really don't understand. Why does the virus not come back? Understanding these markers will help that, but also it'll help build an algorithm to help try and predict patients who've been on therapy from primary infection, maybe for 2 or 3 years. If we measure these sort of markers, we may be able to say, well, you can come off and see how you get on. You may do well. We don't know the answer to that yet, but it's the first steps.